Okay, good evening, everyone. Welcome to O-Level Physics lesson. Today is the 10th of July, 2023. Okay, my name is Mr. Chu, and we'll continue with our second theory lesson on this topic of energy. Okay. So let me just summarize what we have learned in the last lesson. Okay, so let me show you all the syllabus. Okay, so the last lesson we have covered two parts. We have covered energy store and transfer. So basically it is from A to C. Okay, so we have learned this last week. Okay. Hello, Xuan. Okay, so we have learned this last week. So let me just, okay, so not last week, 2 weeks ago. So let me just briefly summarize what did we learn 2 weeks ago. Okay, first of all, okay, there are 6 types of energy store. Okay, 6 types of energy store. Okay, there are 6. Okay, so they are the energy in the kinetic store. Okay, energy in the kinetic store, energy in the gravitational potential store, energy in the chemical potential store, energy in the elastic potential store, energy in the nuclear store, and energy in the internal store. Okay, so these are the 6 types of energy store that you all need to know. Okay, then the second thing you all need to know is that energy can be transferred from one store to another. Okay, 4 ways. Okay, 4 ways. Okay, by a force acting over a distance, that is mechanical way. By an electrical current, that is by the electrical way. Okay, because of temperature difference, that is by the heating way. And also by propagation of wave, either electromagnetic wave or a mechanical wave. Okay, so energy can be transferred from a store to another store. Is that clear? Okay, so for your batch onwards, the different type of model that you all are learning, it's not that science has changed. It's just that this is a different model. Okay, this is a different model, okay, that you guys are actually exposed to, which actually model energy, okay, by store. Okay, we have a store of energy. Okay, so that is the difference, okay, between, okay, what you learn versus what your senior learn. Okay, it's just a different model, okay, about how energy is actually being taught to you. Okay, the science is still the same. It's just a different model that's being used to teach. Okay, just like, for example, if you have learned chemistry, you have learned the model of a molecule. There's a or atom. There's a lot of different models that people use, okay, to study or to teach what an atom or molecule is. Okay, so you all will have learned the like the planet model, right? But in actual fact, that is not the best model to learn. Okay, so same thing over here for energy. Okay, for your batch onwards, you are using this energy store as a model to study energy. Okay, so that's a bit different compared to what your senior are learning. Okay, but your formulas, everything else is all the same. Okay, the next thing that you all need to know is that energy in the kinetic store, the formula is half mv squared, and energy in the gravitational potential store is mgh. Okay, that's the second thing that you all have learned 2 weeks ago. Okay, lastly, you all will need to know what is the principle of conservation of energy. Okay, so basically it states that energy cannot be created or destroyed. It can only be transferred from one store to another. The total energy in an isolated system is always the same. It doesn't increase or decrease. Is that clear? Okay, so are you clear about part A, B, and C? If you are clear, I'm going to talk about the next one. Okay, which is the work. Okay, I'm going to talk about work soon. But do you have any question regarding A, B, and C? You got a question, please let me know. Please let me know. Hey, Shishan, hello, welcome to the class. Can you on your camera? Okay, so let's look at part D. Okay, we're going to talk about work today. Okay, so work itself is force times distance moved in the direction of the force. Can I repeat myself again? Work is force multiplied by the distance moved in the direction of the force. Okay, so this S here, okay, distance moved in the direction, in a short form is called displacement. And displacement you have learned previously, the short form is S. Okay, so the formula of work done is force times S. Is that clear? Okay, so so previously, do you remember what does energy means? Okay, energy. Previously, I actually explained what is energy. Energy is required, okay, for things to work. Okay, energy is required for things to work. Okay, so we are looking at this term here called work. Okay, what does this work means? Okay, so work actually is force multiplied by the distance moved in the same direction of the force. Okay, so work is equal to force times displacement. Okay, this displacement has to be in the same direction as this force. Okay, so I put a parallel line here because this S has to be in the same direction as the force. Okay, so far, okay? Okay, energy has a unit of joule. Work has also the energy of joule. So basically, energy is required to do work. I repeat myself again. Energy is required, okay, for work to be done. And what is work? Work is a product of the force, okay, and the distance moved in the direction of the force itself. Okay, are you clear about this so far? Okay, if you are clear, okay, all of you type down W equal to Fs in the chat. Okay, Zachary, your S should be small letter. C, well done. Ray Hong, your W and F has to be capital letter. Try again. Okay, Zachary, well done. Shishan, well done. Okay, Ray Hong, well done. Okay, so This is the first thing that you're going to learn today. Work actually is the product of the force and the distance moved in the direction of the force. So for example, if all of you are pushing against the wall, okay, all of you are pushing against the wall, is there any work done? So can I answer the question? Yes or no? If all of you are pushing against the wall, are you doing any work? Ray Hong say no. Si Ren say no. How about Zachary and Sishen? Both all of you are pushing against the wall. Okay, are you all doing any work? Okay, Zachary say no. Okay, very good. Okay, I'm going to give you another example. Okay, if you were to hold, okay, all of you have handphone, right? If you hold your phone on your hand, just holding on your hand like this. Okay, holding your hand like this. Are you doing work? Just holding for 1 hour. Just holding your phone, okay, for 1 hour. Are you doing work? Okay, so if you are holding your phone, so for example, this is your phone. Okay, your force is, your hand is applying a force upwards, but your phone did not move. Okay, your phone does not have a displacement. Okay, yes, you apply a force upward because your hand feel very aching, right? Because you need to apply a force to hold the phone in your hand. Okay, but because the phone did not work, okay, the phone did not do any work. Okay, because your distance of the object move in the direction of the force is 0. Okay, so the force did not move. It's right, of course. There's a force, but there is no work done. Is that clear? Okay, because your distance moved by your book in the direction of the force is 0. So F times 0 will be equal to 0. No work is done. Clear so far? Okay, how about if you're holding the phone and you're walking from left to right? You're holding your phone and walking from left to right. Is there any work done? You are holding your phone, but you are moving from left to right. Siren say no. How about the rest of you? How about the rest of you? You're holding, okay, I'm holding my iPad. Then I walk from left to right at the same height. My iPad is at the same height by moving myself from left to right of the room. So am I doing work? Is this iPad doing any work? Is any work is done on the iPad? Okay, very good. Ray Hong say no. Sishen say no. Zachary say no. Okay, so why? There is a distance move. Left to right, maybe I move 2 meters. I apply a force, maybe 10 Newton. Okay, so I apply a 10 Newton force and I move from left to right of 2 meters. I put in the formula here, but why do you all say no? 10 times 2 should be 20 what? There should be 20 joule of work done on the book. Okay, so why do you all say no work is done on the book? Okay, the reason is because your force of holding the book is upwards, or your phone, sorry. Your force of holding your phone is upwards, 10 Newton. Okay, the distance moved by your phone in the same direction. In this case, is it 2 or 0? Okay, in this case, is it 2 or 0? So for this case, it is 0 because the phone did not move in the same direction as the force. Your S is 0, is parallel to the force, is 0. So there will be no work done on the phone. Okay, so all of you say no, that is correct. Are you clear about this? Now, another scenario. Are you clear about this? Let me go through another scenario. You're on the road, there is the box, and you push the box. There's a force. You push the box, and the box moves 3 meters. Okay, so in this scenario, is there work done on the box? Ray Hong, very fast, tell me yes. How about the rest of you? Siren say yes. Zachary say yeah. Yeah. Zixuan, how about you? Is there any work done by on the box? Okay, so in this case, there is a force acting on the box. So there is a F. The box, is it moving in the direction of the force? So in this case, yes, it's moving in the direction of force. So there is a direction, there's a displacement in the direction of the force. So there is a force, there is a direction there is a distance move in the direction of the force. So therefore, work is done on the box. Is that clear? Okay, so the box actually, there is actually work done on the box. Clear so far? Okay, so you all understand this concept? Then I'll move on to the next one called power. Okay, I'm going to talk about power next. Okay, so power basically is okay, how do I explain power? Okay, let me change the whole thing again. Let me erase the work done. Okay, so we know that power, you look at this formula here, is energy transferred over time. And we are also convinced that energy and work are the same. So you can also say that it's work over time. Okay, so what is the meaning of power? Okay, so let me ask you a question. If you use more energy or you do more work in a same period of time, same unit of time, for example, 1 minute, you use up more energy or you do more work, but in the same amount of time, are you more powerful or less powerful? So tell me, are you more powerful or less powerful? More or less? If you are going to use up more energy in 1 minute compared to another person using less energy in 1 minute, are you more powerful or less powerful? You all need me to repeat myself again. If you are going to do more work in 1 minute compared to another person going to do less work in 1 minute, are you more powerful or less powerful? Okay, Ray Hong say more. Shi Xuan say more. How about Siren and Zachary? Are you more powerful if you use up more energy or you do more work in the same amount of time? Okay, Zachary say more. How about Siren? Siren say more. So, are you convinced that power is proportional to energy or time? Yes or not time? Energy or work done? Okay, are you convinced about this? You have more power if you use up more energy or use up more work or do more work. Are you convinced about that? Okay, that's what the formula here tells you. As your E increases, your P will increase. Or as your W increases, your P will increase. Clear about that? Okay, now let me ask you another question. All of you do the same amount of work. Okay, 100 joules of work. But A did it in 1 second and B did it in 2 seconds. So who is more powerful? A do it in 1 second or B do in 2 seconds? Who is more powerful? Okay, Ray Ho and Shi Xuan, well done. How about Siren and Zachary? A and B do the same amount of work, but A did it in half the time as B. So who is more powerful? Okay, Siren, well done. How about Zachary? Okay, so are you convinced that if you use more time to use the energy, or you use more time to do the work, you are less powerful? Are you convinced about that? So power is inversely proportional to time. Okay, so up to now, you all know that this is the formula of power. Are you convinced? Okay, so what is the definition of power? Do you all remember in the previous topic, when you see divide by T? Do you remember I talked to you about divide by T? Okay, for example, okay, velocity is your displacement over time. Okay, speed is your distance over time. Acceleration is your change of V over time. When you see divide by T, how do you define the variable? Okay, so let me practice. Speed is the rate of change of distance. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. So now, can you tell me what is power? Power is the rate of energy transferred or rate of work done. Are you clear? When you see rate of, okay, it means divide by T. Okay, are you clear? When you see divide by T, your definition will be rate of something. Okay, so power, okay, can you see here? Power is the energy transfer divided by time. is also the same as work done over time. Okay, so you want to define what's the meaning of power. You just say that power is the rate of energy transferred, or power is the rate of work done. Are you all clear about this? So in future, let me just emphasize again. If you see your formula that is divided by T, you can quickly say that the definition of this variable is the rate of this variable. Are you all clear about this? Okay, so far? Are you all with me? Okay. So to test you, let me give a example question. Okay. So for example, Ray Hong weighs 450 Newton. He climbed up a stairs. Okay. The step is 0.20 meter high each. Okay, and he takes 5 seconds to run up 10 steps. Okay, what is the power? Okay, so I want to calculate what is the power exerted by Ray Hong. Okay, what is the power exerted by Ray Hong? Can you all try that now? Zachary, I will need your units. Yeah, your magnitude is incorrect. Try again, Zachary. Siren incorrect. Okay, the question is power. Okay, Siren, what is your unit in joule? Joule is for energy or work done. Okay, now we're talking about power. Okay, what's the power exerted by Rui Hong? Rui Hong incorrect. Okay. How about Sishen? Are you able to get the answer? So you got one person with a mass of 450 Newton. Okay, going up 10 steps. 10 steps of 0.2 meters is 2 meters. Okay, so what is the work done by Rui Hong by going up 2 meters? Okay, the work done is force times S. In this case, 450 Newton times 2 meter. You get 900 joule. Am I right? So the work done by Rui Hong to climb up 10 steps is 900 joule. So what is the power exerted by Rui Hong? It takes 5 seconds to do that. So what is the power? Okay, so now you know that the work done is 900 joule. What is the power exerted by Rui Hong? Okay, Siren, well done. How about the rest of you? Hello, time to work. Time to work. Ray Hong incorrect. How do you get the answer? 900 joule. Okay, your work done is 900 joule. Your time is how long? Time is 5 seconds. So what's your answer? Hey, are you all with me or not? It's a very simple question. Up to now already you should be able to do it. Okay, Ray Hong, well done. Siren, well done. Sishan and Zachary, can I have your answer, please? Okay, Sishan, I have not talked about the unit of work done. Okay, so your unit is correct, not wrong, but there's an SI unit for power. Okay, later I'll explain. Zachary, that's incorrect. The 900 joule is for work done. I'm talking about power. What's the power by Ray Hong? You can tell from my voice that I'm very disappointed that you are not with me. I'm actually asking a very, very simple question, but you are taking a long time. You are not with me in listening to class. I want to see the unit, Zachary. Okay, I've been explaining this for many, many times. Quantity is meaningless without a unit. So can you write down the unit as well? Okay, you can see over here, the unit for energy is joule. The unit for work done is joule. The unit for time is second. Okay, so what is the unit for power? It is joule over second. Okay, but to actually honor a scientist, okay, this joule over second is the same as watt. Okay, so from here, how do I count do the working? Power is equal to the work done over time. Your work done in this case 900 joule divided by 5 seconds, and therefore the power exerted by Ray Hong is 180 watts. Are you all clear about this? Okay, if you are clear, give me a yes reaction. Sishan and Ray Hong, are you okay? Sishan, you okay? Okay, I'm going to talk about efficiency now, which is F. for a perfect machine, okay, for a perfect machine, okay, the energy output will be equal to the energy input. I repeat myself again. For a 100% perfect machine, the energy output will be equal to the energy input. Okay, so instead of using the word perfect, you can also say that in an ideal machine, the total energy output should be equal to the total energy input. This means that no energy is lost. Okay, all energy are being transferred to become useful energy. I repeat, in an ideal machine, all your energy input is transferred to become useful energy output. There is no non-useful energy. However, practically, to get an ideal machine is almost impossible. Okay, some of the energy will be lost as heat, okay, or even sound, okay, or even light, or even heat. Okay, some energy are lost, okay, are lost as heat or sound. Okay, so therefore, to find how efficient a machine is, we use the formula. Efficiency will be the useful energy output divided by the total energy input. Okay, multiply by 100%. Are you all clear about that? So for example, have you all been to the north of Singapore? Have you all seen the Senoko power station? Okay, so when you generate electricity in a power station, okay, for example, if you are using a coal power station, you burn the coal, right? And then the coal heat up the water actually will move the turbine. And as the turbine turns, it actually generates electricity. However, in this whole process, some of the energy is dissipated or lost as non-useful energy. Okay, for example, what are the non-useful energy? The heat energy and so on. Okay, so what is the heat energy? Heat energy actually is the internal energy in the internal store of the surrounding. Okay, so the energy is being transferred, okay, transferred from the internal store of the coal to the internal store of the surrounding. And this internal store of the surrounding is considered as non-useful energy. So it's actually not a useful energy. So therefore, your power station is not 100% efficient. Is that clear? Okay, because this energy that you transfer to, which is the internal energy, energy in the internal store of the surrounding, cannot be used to power motor or light. Okay, so for example, the Senoko power station, the efficiency is about maybe 50%. Okay, do you remember your food chain in primary school? Your food producer are the plants. Then you got the food consumer, the primary consumer, secondary consumer. Okay, so energy is also being transferred from the sun, okay, to the plant, and then from the plant to the primary consumer and so on. Okay, and you know that not 100% of this energy is transferred from one to the other. Okay, so for example, when energy is transferred from the living thing to the surrounding, like when you breathe, okay, you actually transferring some of the energy to the surrounding. So not all energy is transferred from the producer to the primary consumer to the secondary consumer. Okay, so the useful energy output is also always less than the energy input. Okay, so I'm just linking to what you all learned in primary school in a food chain. Okay, your energy, the efficiency of your food chain is very low. Okay, less than 10%. Is that clear? Okay, less than 10%. Okay, so if we want to have a sustainable future, okay, what should we do? Okay, maybe we should try to consume vegetable more, or we try to consume primary consumer, that is the animals that feed on plants. Okay, you all understand what I mean? Because as the food chain move down the lane, the efficiency become lesser and lesser. You are losing a lot of useful energy. So if we really want to have a sustainable food for the population on Earth, we may want to consider eating more vegetable or plant-eating animal rather than eating secondary consumer like a tiger. Okay, don't eat tiger because they don't eat plant, they eat animal. So by the time the energy reach the tiger, okay, most of the energy is really lost to the surrounding. Are you clear about that? Okay, so let me go through an example. Okay, let me go through an example. But before that, let me just highlight efficiency first. Okay, you have a lamp that is on for 5 minutes. So 12 kilojoule of energy was transferred to the lamp. Okay, assuming 100% efficiency, what is the power of the lamp? So can all of you calculate this down? Shi can you convert it to the SI unit of what? Okay, Cyril, well done. Wei Hong incorrect, ah. Shixuan incorrect. Shixuan, can you convert that to what? Zachary, talking about what is the power of the lamp? Why you give me the unit in joules? Okay, so energy in this case is 12,000 joule. Okay, 5 minutes is equal to how many seconds? Okay, 300 seconds. Okay, so basically power is energy divided by time equal to 12,000 joule divided by 300 seconds. And from here, what's your answer? Okay, the unit should be what? Okay, Zachary, can you try again? Cyril, well done. Rui Hong incorrect. Shixuan incorrect. So all try again. Okay, Zachary, can you write down the short form for what? What is the symbol for what? Okay, well done, Zachary. Well done, Cyril. Rui Hong and Shixuan, what's your answer? Okay, well done, Zachary. Okay, Rui Hong, what's the short form for what? Okay, Rui Hong, well done. Okay, so in this case, the answer will be 40 watts. Is that clear? Okay, I don't know why you are like, having some difficulty in this thing. It's not that hard of a question. Eh. Let me ask you another question. Okay, so a machine produces 35 joule of useful output energy for every 50 joule, 50 joule of total energy input. So what is the efficiency of the machine? Okay, can you calculate it now? Okay, Ray Hong, why you got answer 70 what one? Asking the question asking what's the efficiency? Efficiency is in percentage. Okay, see, very well done. Shishen, well done. Zachary, incorrect. Ray Hong, incorrect. Okay, so what's the formula for efficiency? Efficiency is useful energy output over total energy input times 100%. So what do I get from here? $35 joule over 50 joule times 100%. So what's the final answer? Zachary, I want to have a unit. Don't just give me answer without a unit. Because 70 and 70% is a very different thing. Wrong. Efficiency is not in joule. Okay, so the answer will be 70%. Is that clear? Okay, up to now, we have talked about a lot of formulas. Okay, I'm going to highlight the formulas again. Okay, we have talked a lot about formulas, these two lessons. Okay, we have this formula, number 1, number 2, number 3, number 4, and number 5. Okay, are you clear about this? Okay, these are the 5 formulas that you have actually learned so far today. Okay, so I'm going to go through the last part of this lesson. Okay, the last part will be about energy resources. Okay, where we are going to discuss the use of non-renewable energy resources such as fossil fuel and nuclear fuel, and renewable energy resources such as biofuel, wind, tides, hydropower, geothermal reservoir, and solar to generate electricity in terms of efficiency of energy transfer, cost, reliability, and their environmental impact. Okay, so let me first talk about, okay, all these are I will not be giving you all notes because all your textbook, but let me explain to you all first. Okay, so there's 2 types of energy. Okay, there's 2 types of energy. One is the renewable and the other one is non-renewable. Non-renewable means that once you use it, okay, once you use it, it will not cannot be reused. Okay, whereas renewable energy, okay, is always there. Are you clear so far? Okay, so as we move forward, this is something new. This is something new that you are learning compared to your seniors. Okay, your seniors did not learn that much in detail. Okay, you are going to learn more in detail in this part in part G. Okay, so for energy, which energy should we use? Okay, if you are a government of Singapore or your government of a little island or little kingdom, what type of energy can we use? Can you see down here? There are so many types of energy. There's fossil fuel, nuclear fuel, biofuel, wind, tides, hydropower, geothermal, solar, etc., etc. Okay, so you will need to actually compare. Okay, you need to actually compare how efficient the energy transfer is versus the cost versus the reliability. For example, if you want to use wind energy and the whole year round, some months got a lot of wind and other months got no wind. Okay, the kind of reliability depends on where you are and so on. Okay, so you need to actually know all this stuff. So first, I'm going to talk about fossil fuel. Okay, so fossil fuel are things like oil, petroleum, natural gas, wood, or coal. Okay, so these are the very traditional fossil fuel. Okay, what is the advantage of fossil fuel? Okay, what's the advantage? It is actually very reliable. Okay, actually they are very reliable. It doesn't depend on your wind or the sun or your weather and so on. Okay, and it's actually quite cheap compared to other fuel. Okay, but the thing that is not very good about fossil fuel is that it is non-renewable and it actually produces pollution. Okay, not a very sustainable energy source. Clear so far? Okay, then the next thing that we're going to talk about is nuclear fuel. Okay, Singapore does not use nuclear fuel because we don't have the space. So basically, nuclear fuel will undergo nuclear reaction to release energy. either nuclear fission or nuclear fusion. Nuclear fusion means you got two particles combined together. Okay, nuclear fission is one particle split into two. That's called nuclear fission. Okay, so that is how nuclear energy is actually being produced. Okay, so the advantage of a nuclear energy is same like fossil fuel. It doesn't depends on the surrounding. Meaning, if there is a rain, there's no sun, no wind, it can still produces nuclear energy. Okay, and one more advantage of nuclear energy is that it is very clean. Okay, it does not produce much pollution to the environment. Okay, however, what is the bad thing about nuclear energy? Okay, it is that it is non-renewable. Okay, non-renewable, it need to keep on finding new resource. And two very important disadvantage is that there's a risk of accident. For example, recently in Japan, because of earthquake, then the nuclear plant have an accident, and then it polluted the nuclear pollution of the surrounding. Okay, also there is also pollution if you dispose the radioactive waste in not properly. Okay, if you were to dispose the radioactive waste not properly, it will also produce pollution. Okay, and that is harmful to life. Clear so far? Okay, so what is biofuel? Okay, biofuel are things like ethanol, biodiesel, biogas that are derived from biomass. So what is biomass? Biomass could be animal waste. Okay, animal waste or even fruits like corn. Okay, so you actually take all these animal waste or even some plant and then produce fuel. Okay, so what is the advantage of this? Okay, the advantage of all this at the back is all renewable. Okay, biofuel is widely available and it's also pretty affordable. Okay, however, biofuel got this advantage. It can also produce pollution because the gas, okay, that is produced during burning biofuel is similar to fossil fuel. It actually can produce pollution to the environment. Okay, so for wind is a renewable energy. That's a good thing. It is clean, so you don't produce pollution. However, it is not easy to find a place where you can have a sustained power production. Okay, and also the wind turbine produces noise and it takes up space, so you need to actually clear up land or to actually build a wind turbine. Okay, so that's the thing about wind. Okay, tides, you know, tides are produced because of the gravity of the moon. So this is using the moon gravity to produce energy. Okay, so when it's high tide and low tide, actually the wave come in and out. Okay, so it is a renewable energy. That's a good thing. It is tides are more reliable than wind or sun. You all agree or not? Okay, tides occurs every day, every hour, every time. There will always be wave. Okay, whereas wind and sun is only a portion of the day. Okay, and using tides to generate energy is also clean. Okay, however, what's the bad thing about tides? Since tide is so good, what people don't have, and Singapore is an island, we have tides around the island. So why don't we use tides to generate energy? Okay, first of all, it is very expensive at this point of time. And if you build all these tidal turbine and so on, it will actually affect marine life. Okay, your tortoise cannot go to your beach to lay eggs. It got all blocked by the tidal generator. Clear so far? Okay, so what is hydropower? Hydropower is something like it is used in dam. So like you have big rivers flow from a high place to a low place. So you build a dam to stop the river from flowing. Okay, so energy is built up. Then as you let go of the water, it is used to power the turbine. Okay, so that's the advantage of hydropower. Okay, it is a good thing, it's renewable. It can be continually generated, and it is also a clean method of producing electricity. Okay, but what's the bad thing about it? It's a high cost of building. Okay, and also when you dam a river, it might damage the environment surrounding the river. Okay, so when you start to build dam, down your above your dam and below your dam, all your habitat may change. Okay, do you agree? Normally there's a river flowing through, then you put a dam down there, right? Then everything changes before and after the dam. Okay, so the land will change. The people that used to plant things also may need to actually relocate. Clear so far? Okay, second last one, geothermal. Geothermal, there are some areas like places where there's volcano, where there is a geological forces pushing large amount of heat near the Earth's surface. So there are geothermal hotspot. Okay, so geothermal energy is actually very good because it's clean, it's renewable. Okay. However, what's the bad thing about geothermal? Two things. Number one, not widely available. You don't find geothermal reservoir everywhere. And number two, places where there is a geothermal reservoir, okay, they also tends to also produce poisonous gas like hydrogen sulfide. So this type of area can emit poisonous gases and then cause poison or pollution to the environment. Okay, so not all geothermal reservoir, though it is clean, but to come with geothermal energy, it actually comes with poisonous gas release as well. Okay, lastly, in Singapore, we use a lot of solar energy. Okay, because solar power comes from the sun. Okay, so it has the energy from the nuclear store. Okay, so solar energy is good. It is renewable, it is clean. Okay, however, not throughout the day you get sunlight. For example, at night, there is no sunlight. Or when there's a heavy storm, okay, like these few days, there's a heavy rain, then you got less sun shining on the on Singapore. Okay, so solar may not be a very consistent source of energy. And also solar panel takes up a lot of space. So you want to generate enough electricity, you need to use up a lot of space just to collect the solar energy. Okay, up to now, I have gone through all these non-renewable and renewable energy resources. Okay, they are all available in your textbook. Okay, so you have to remember there's nothing much for me to explain this because these are not concepts, these are all facts. Okay, these are all information that you all need to remember. So are you clear about this one, Part G? Any question for me regarding this whole topic of energy? Okay, if there's no question, I have a few checkout questions for you all. Number one, what's the formula for work done? Number two, what's the formula for power? Number three, what's the formula of efficiency? Number four, how much you learned today? And number five, how well Mr. Chu teach today? Okay, once I call your name, if your answer is correct, you may leave the class. Okay, Ray Hong, you may go. Okay, Zachary is the force time displacement. Okay, Zachary may go. Siren is useful energy output, not total energy output. Because total energy output will be the same. It's useful energy output. Okay, Siren, you may go.
Good evening. What can I do for you?
Shishan, your force, number one, your force should be capital letter. Your D should be small s. Okay, your number three should be useful output, energy output. And the letter is, okay, efficiency, use EFF. Don't use the E. E stands for energy. Okay, Shishan, are you clear about this? If you are clear, okay, you may leave the class. Thank you, everyone. Okay, you may leave.